Have you ever wondered if your genes could be the key to unlocking your ideal weight? Welcome to the exciting world of genetic weight management, where scientists are studying our DNA to create personalized diet and exercise plans. Imagine a weight loss strategy tailored just for you. Based on your unique genetic makeup, it sounds like science fiction, but it's happening right now. But as we unlock the secrets of our genes, a critical question emerges. Are we fully aware of what we risk signing up for when we join these studies? Let's dive into the science. Researchers are identifying specific genetic markers, like the FDO and MC4 genes, that influence our metabolism, appetite, and how our bodies store fat. By understanding these variations, they can predict how you might respond to different foods or workouts. This could revolutionize preventive health, making weight loss more effective and reducing obesity-related diseases. But here's the catch: the very data that makes this possible is incredibly personal. Your genetic information is permanent, unique to you, and can reveal predispositions to other health conditions, not just weight. This raises a huge ethical concern. Do participants truly understand the long-term implications of sharing their most intimate biological data? This brings us to the core principle of all ethical research: informed consent. It's not just about signing a form, it's a fundamental promise that you, as a participant, have been given clear, comprehensive information about a study, the risks, the benefits, and how your data will be used. It guarantees your participation is voluntary and that you can withdraw at any time. This principle was born from dark chapters in history, like the Tuskegee syphilis study, which highlighted the devastating consequences of exploiting participants. These events led to the creation of ethical guidelines that emphasize respect for persons, minimizing harm, and ensuring fairness in genetic trials. These principles are put to the test. Respect means ensuring you grasp the lifelong implications of sharing your DNA. Minimizing harm means protecting your data from misuse, and fairness means no single group is unfairly burdened by the research. But achieving true informed consent is harder than it sounds, especially in genetics. First, the science is complex. Terms like genome sequencing or data anonymization can be confusing, leaving participants agreeing to things they don't fully understand. There's a real risk of a gap between what researchers explain and what participants actually comprehend. Then there's the issue of secondary data usage. Once your genetic material is collected, it can be stored and used for future, unrelated studies. And while researchers talk about making data anonymous, complete anonymity with DNA is nearly impossible. This creates a risk of re-identification and potential misuse, especially if the data is shared with commercial companies or insurance providers. This leads to another thorny question: who owns your genetic data once you've given it? In many cases, once you sign the consent form, you lose control. Your genetic information might become the property of the research institution or its corporate partners. You may never be told if your sample is used to develop a profitable drug or patented technology. Beyond the data, there are the emotional and psychological impacts. Learning you have a genetic predisposition to obesity can trigger anxiety, guilt, or feelings of hopelessness. A truly informed consent process should prepare participants for these potential emotional responses, but this is often overlooked in the rush to collect data to protect participants. Legal frameworks like the Genetic Information Non-Discrimination Act (GINA) in the US and the GDPR in Europe exist. GINA, for instance, prohibits employers and health insurers from using your genetic information against you. These laws are crucial, but they don't solve the core problem if participants don't understand the extent of data sharing in the first place. The responsibility falls on researchers and institutions to make consent a meaningful, transparent process, not just a legal checkbox. So, how can we do better? To uphold ethical standards, research institutions need to adopt several best practices. First, simplify consent forms. They should be written in plain, easy-to-understand language, using visuals or analogies to explain complex ideas like gene sequencing. Second, think of consent as an ongoing conversation, not a what-time event. Participants should be updated on new findings or changes in data use, with the option to opt out at any stage. Third, transparency is key. Researchers must be upfront about any commercial partnerships or data-sharing agreements. This builds trust and empowers participants. And finally, data security is non-negotiable. Genetic data must be protected with robust encryption and strict access controls because, unlike a password, you can't change your DNA. One of the growing challenges is consent fatigue. We're constantly asked to agree to terms and conditions online, and this can make the consent process feel like a routine chore rather than a serious ethical decision. In genetic trials, where you might sign multiple forms for the study, data storage, and future research, this fatigue is a real danger. It can lead to participants skimming through documents and missing crucial information. To combat this, researchers are exploring interactive consent methods like short videos or quizzes that test comprehension before allowing a participant to proceed. These tools can make the process more engaging and ensure a deeper level of understanding. Ultimately, ethical research is a delicate balance between the drive for scientific innovation and the duty to protect participants. The pressure to publish quickly or secure funding can sometimes tempt institutions to cut corners on consent. But scientific progress should never come at the expense of individual rights. The case of Henrietta Lacks is a powerful reminder of this. In 1951, cells were taken from her without her knowledge or consent. These HeLa cells became the first immortal human cell line and have been instrumental in countless medical breakthroughs, yet she and her family were never informed or compensated. We must ensure that participants in today's genetic studies don't unknowingly contribute to commercial products without their explicit permission. Looking ahead, technology itself might offer solutions. Blockchain could create secure, transparent records of consent, while AI could help analyze consent forms to ensure participants understand key terms. But these tools must supplement, not replace, the human element of trust and communication. The future of ethical genetic research depends on a partnership between scientists, ethicists, and the public. Participants are not just subjects of discovery, they are partners in the journey. In the end, informed consent in genetic weight management studies isn't just a bureaucratic hurdle, it's a moral pact. As we continue to explore the genetic basis of health, we must champion autonomy, transparency, and justice. A signature on a form is meaningless without true understanding. By prioritizing ethical integrity, we can ensure that the future of genetic research is not only scientifically groundbreaking, but also profoundly responsible. Thank you for watching. If you found this video insightful, please give it a thumbs up, subscribe to our channel, and hit the notification bell to stay updated on our latest content.